Item 360. Concrete pavement. 1. Description. Construct hydraulic cement concrete pavement with or without curbs on the concrete pavement. 2. Materials. 2.1 Hydraulic cement concrete. Provide hydraulic cement concrete in accordance with Item 421, Hydraulic cement concrete. Use compressive strength testing unless otherwise shown on the plans. Provide Class P concrete designed to meet a minimum average compressive strength of 3,200 psi or a minimum average flexural strength of 450 psi at 7 days or a minimum average compressive strength of 4,000 psi or a minimum average flexural strength of 570 psi at 28 days. Test in accordance with TEX 448A or TEX 418A. Obtain written approval if the concrete mix design exceeds 520 pounds per cubic yard of cementitious material. Use coarse aggregates for continuously reinforced concrete pavements to produce concrete with a coefficient of thermal expansion not more than 5.5 times 10 to 6 in/degree F. Provide satisfactory TEX 428A test data from an approved testing laboratory if the coarse aggregate coefficient of thermal expansion listed on the department's concrete rated source quality catalog is not equal to or less than 5.5 times 10 to 6 in/degree F. Provide Class E's concrete for very early opening of small pavement areas or leave-outs to traffic when shown on the plans or allowed. Design Class E's to meet the requirements of Class P and a minimum average compressive strength of 3,200 psi or a minimum average flexural strength of 450 psi in 24 HR, unless other early strength and time requirements are shown on the plans or allowed. Use Class A or P concrete meeting the requirements of Item 421, hydraulic cement concrete, and this item for curbs that are placed separately from the pavement. 2.2 Reinforcing steel. Provide grade 60 or above, deformed steel for bar reinforcement in accordance with Item 440, reinforcement for concrete. Provide positioning and supporting devices, baskets and chairs, capable of securing and holding the reinforcing steel in proper position before and during paving. Provide corrosion protection when shown on the plans. 2.2.1 Dowels. Provide smooth, straight dowels of the size shown on the plans, free of burrs, and conforming to the requirements of Item 440, reinforcement for concrete. Coat dowels with a thin film of grease, wax, silicone or other approved debonding material. Provide dowel caps on the lubricated end of each dowel bar used in an expansion joint. Provide dowel caps filled with a soft compressible material with enough range of movement to allow complete closure of the expansion joint. 2.2.2 Tie bars. Provide straight deformed steel tie bars. Provide either multiple piece tie bars or single piece tie bars as shown on the plans. Furnish multiple piece tie bar assemblies from the list of approved multiple piece tie bars that have been pre-qualified in accordance with DMS 4515. Multiple piece tie bars for concrete pavements, when used. Multiple piece tie bars used on individual projects must be sampled in accordance with TEX 711I, and tested in accordance with DMS 4515. Multiple piece tie bars for concrete pavements. 2.3 Alternative reinforcing materials. Provide reinforcement materials of the dimensions and with the physical properties specified when allowed or required by the plans. Provide manufacturer's certification of required material properties. 2.4 Curing materials. Provide Type 2 membrane curing compound conforming to DMS 4650, hydraulic cement concrete curing materials and evaporation retardants. Provide SS1 emulsified asphalt conforming to Item 300, asphalts, oils, and emulsions, for concrete pavement to be overlaid with asphalt concrete under this contract unless otherwise shown on the plans or approved. Provide materials for other methods of curing conforming to the requirements of Item 422, concrete superstructures. Provide insulating blankets for curing fast-track concrete pavement with a minimum thermal resistance, R, rating of 0.5 hour square foot F/BTU. Use insulating blankets that are free from tears and are in good condition. 2.5 Epoxy. Provide Type 3, Class C epoxy in accordance with DMS 6100, epoxies and adhesives, for installing all drilled-in reinforcing steel. Submit a work plan and request approval for the use of epoxy types other than Type 3, Class C. 2.6 Evaporation retardant. Provide evaporation retardant conforming to DMS 4650, hydraulic cement concrete curing materials and evaporation retardants. 2.7 Joint sealants and fillers. Provide Class 5 or Class 8 joint sealant materials and fillers unless otherwise shown on the plans or approved, and other sealant materials of the size, shape, and type shown on the plans in accordance with DMS 6310, joint sealants and fillers. 3. Equipment. Furnish and maintain all equipment in good working condition. Use measuring, mixing, and delivery equipment conforming to the requirements of Item 421, hydraulic cement concrete. Obtain approval for other equipment used. 3.1 Placing, consolidating, and finishing equipment. Provide approved self-propelled paving equipment that uniformly distributes the concrete with minimal segregation and provides a smooth machine-finished consolidated concrete pavement conforming to plan, line and grade. Provide an approved automatic grade control system on slip-forming equipment. Provide approved mechanically operated finishing floats capable of producing a uniformly smooth pavement surface. Provide equipment capable of providing a fine, light water fog mist. When stringless paving equipment is used, use Section 5.9.3, Method C, and establish control points at maximum intervals of 500 feet. Use these control points as reference to perform the work. Provide mechanically operated vibratory equipment capable of adequately consolidating the concrete. Provide immersion vibrators on the paving equipment at sufficiently close intervals to provide uniform vibration and consolidation of the concrete over the entire width and depth of the pavement and in accordance with the manufacturer's recommendations. Provide immersion vibrator units that operate at a frequency in air of at least 8,000 cycles per minute. Provide enough hand-operated immersion vibrators for timely and proper consolidation of the concrete along forms, at all joints and in areas not covered by other vibratory equipment. Surface vibrators may be used to supplement equipment-mounted immersion vibrators. Provide tachometers to verify the proper operation of all vibrators. For small or irregular areas or when approved, the paving equipment described in this section is not required. 3.2 Forming equipment. 3.2.1 Pavement forms. Provide metal side forms of sufficient cross-section, strength, and rigidity to support the paving equipment and resist the impact and vibration of the operation without visible springing or settlement. Use forms that are free from detrimental kinks, bends, or warps that could affect ride quality or alignment. Provide flexible or curved metal or wood forms for curves of 100 feet radius or less. 3.2.2 Curb forms. Provide curb forms for separately placed curbs that are not slip-formed that conform to the requirements of Item 529, concrete curb, gutter, and combined curb and gutter. 3.3 Reinforcing steel inserting equipment. Provide inserting equipment that accurately inserts and positions reinforcing steel in the plastic concrete parallel to the profile grade and horizontal alignment in accordance to plan details when approved. 3.4 Texturing equipment. 3.4.1 Carpet drag. Provide a carpet drag mounted on a work bridge or a manual movable support system. Provide a single piece of carpet of sufficient transverse length to span the full width of the pavement being placed and adjustable so that a sufficient longitudinal length of carpet is in contact with the concrete being placed to produce the desired texture. Obtain approval to vary the length and width of the carpet to accommodate specific applications. 3.4.2 Tining equipment. Provide a self-propelled metal tine device equipped with steel tines with cross-section approximately 1/32 inches thick times 1/12 inches wide. Provide tines for transverse tining equipment spaced at approximately 1 inch, center to center, or provide tines for longitudinal tining equipment spaced at approximately 3/4 inches, center to center. Manual methods that produce an equivalent texture may be used when it is impractical to use self-propelled equipment, such as for small areas, narrow width sections, and in emergencies due to equipment breakdown. 3.5 Curing equipment. Provide a self-propelled machine for applying membrane curing compound using mechanically pressurized spraying equipment with atomizing nozzles. Provide equipment and controls that maintain the required uniform rate of application over the entire paving area. Provide curing equipment that is independent of all other equipment when required to meet the requirements of Section 360.4.9, Curing. Hand-operated pressurized spraying equipment with atomizing nozzles may only be used on small or irregular areas, narrow width sections, or in emergencies due to equipment breakdown. 3.6 Sawing equipment. Provide power-driven concrete saws to saw the joints shown on the plans. Provide standby power-driven concrete saws during concrete sawing operations. 3.7 Grinding equipment. Provide self-propelled powered grinding equipment that is specifically designed to smooth and texture concrete pavement using circular diamond blades when required. Provide equipment with automatic grade control capable of grinding at least a 3 feet width longitudinally in each pass without damaging the concrete. 3.8 Testing equipment. Provide testing equipment regardless of job control testing responsibilities in accordance with Item 421, hydraulic cement concrete, unless otherwise shown on the plans or specified. 3.9 Coring equipment. Provide coring equipment capable of extracting cores in accordance with the requirements of TEX 424A when required. 3.10 Miscellaneous equipment. Furnish both 10 feet and 15 feet steel or magnesium long-handled, standard straight edges. Furnish enough work bridges, long enough to span the pavement, for finishing and inspection operations. For construction. Obtain approval for adjustments to plan grade line to maintain thickness over minor subgrade or base high spots while maintaining clearances and drainage. Maintain subgrade or base in a smooth, clean, compacted condition in conformity with the required section and established grade until the pavement concrete is placed. Keep subgrade or base damp with water before placing pavement concrete. Adequately light the active work areas for all nighttime operations. Provide and maintain tools and materials to perform testing. 4.1 Paving and Quality Control Plan. Submit a paving and quality control plan for approval before beginning pavement construction operations. Include details of all operations in the concrete paving process, including methods to construct transverse joints, methods to consolidate concrete at joints, longitudinal construction joint layout, sequencing, curing, lighting, early opening, leave-outs, sawing, inspection, testing, construction methods, other details and description of all equipment. List certified personnel performing the testing. Submit revisions to the paving and quality control plan for approval. 4.2 Job control testing. Perform all fresh and hardened concrete job control testing at the specified frequency unless otherwise shown on the plans. Provide job control testing personnel meeting the requirements of Item 421, hydraulic cement concrete. Provide and maintain testing equipment, including strength testing equipment at a location acceptable to the engineer. Use of a commercial laboratory is acceptable. Maintain all testing equipment calibrated in accordance with pertinent test methods. Make strength testing equipment available to the engineer for verification testing. Provide the engineer the opportunity to witness all tests. The engineer may require a retest if not given the opportunity to witness. Furnish a copy of all test results to the engineer daily. Check the first few concrete loads for slump and temperature to verify concrete conformance and consistency on start-up production days. Sample and prepare strength test specimens, 2 specimens per test, on the first day of production and for each 3,000 square yard or fraction thereof of concrete pavement thereafter. Prepare at least 1 set of strength test specimens for each production day. Perform slump and temperature tests each time strength specimens are made. Monitor concrete temperature to ensure that concrete is consistently within the temperature requirements. The engineer will direct random job control sampling and testing. Immediately investigate and take corrective action as approved if any contractor test result, including tests performed for verification purposes, does not meet specification requirements. The engineer will perform job control testing when the testing by the contractor is waived by the plans. However, this does not waive the contractor's responsibility for providing materials and work in accordance with this item. 4.2.1 Job Control Strength. Use 7-day job control concrete strength testing in accordance with TEX 448A or TEX 418A unless otherwise shown on the plans or permitted. Use a compressive strength of 3,200 psi or a lower job control strength value proven to meet a 28-day compressive strength of 4,000 psi as correlated in accordance with TEX 427A for 7-day job control by compressive strength. Use a flexural strength of 450 psi or a lower job control strength value proven to meet a 28-day flexural strength of 570 psi as correlated in accordance with TEX 427A for 7-day job control by flexural strength. Job control of concrete strength may be correlated to an age other than 7 days in accordance with TEX 427A when approved. Job control strength of Class He's concrete is based on the required strength and time. Investigate the strength test procedures, the quality of materials, the concrete production operations, and other possible problem areas to determine the cause when a job control concrete strength test value is more than 10% below the required job control strength or when 3 consecutive job control strength values fall below the required job control strength. Take necessary action to correct the problem, including redesign of the concrete mix if needed. The engineer may suspend concrete paving if the contractor is unable to identify, document, and correct the cause of low-strength test values in a timely manner. The engineer will evaluate the structural adequacy of the pavements if any job control strength is more than 15% below the required job control strength. Remove and replace pavements found to be structurally inadequate at no additional cost when directed. 4.2.2 Split Sample Verification Testing. Perform split sample verification testing with the engineer on random samples taken and split by the engineer at a rate of at least 1 for every 10 job control samples. The engineer will evaluate the results of split sample verification testing. Immediately investigate and take corrective action as approved when results of split sample verification testing differ more than the allowable differences shown in Table 1, or the average of 10 job control strength results and the engineer's split sample strength result differ by more than 10%. Table 1. Verification testing limits. See table in specifications. 4.3 Reinforcing steel and joint assemblies. Accurately place and secure in position all reinforcing steel as shown on the plans. Place dowels at mid-depth of the pavement slab, parallel to the surface. Place dowels for transverse contraction joints parallel to the pavement edge. Tolerances for location and alignment of dowels will be shown on the plans. Stagger the lap locations so that no more than 1/3 of the longitudinal steel is spliced in any given 12 feet width and 2 feet length of the pavement. Use multiple piece tie bars, drill and epoxy grout tie bars, or, if approved, mechanically inserted single piece tie bars at longitudinal construction joints. Verify that tie bars that are drilled and epoxied or mechanically inserted into concrete at longitudinal construction joints develop a pull-out resistance equal to a minimum of 3/4 of the yield strength of the steel after 7 days. Test 15 bars using ASTM E488. Except that alternate approved equipment may be used. All 15 tested bars must meet the required pull-out strength. Perform corrective measures to provide equivalent pull-out resistance if any of the test results do not meet the required minimum pull-out strength. Repair damage from testing. Acceptable corrective measures include but are not limited to installation of additional or longer tie bars. 4.3.1 Manual placement. Secure reinforcing bars at alternate intersections with wire ties or locking support chairs. Tie all splices with wire. 4.3.2 Mechanical placement. Complete the work using manual placement methods described above if mechanical placement of reinforcement results in steel misalignment or improper location, poor concrete consolidation, or other inadequacies. 4.4 Joints. Install joints as shown on the plans. Joint sealants are not required on concrete pavement that is to be overlaid with asphaltic materials. Clean and seal joints in accordance with item 438, cleaning and sealing joints. Repair excessive spalling of the joint saw groove using an approved method before installing the sealant. Seal all joints before opening the pavement to all traffic. Install a rigid transverse bulkhead, for the reinforcing steel, and shaped accurately to the cross-section of the pavement when placing of concrete is stopped. 4.4.1 Placing reinforcement at joints. Complete and place the assembly of parts at pavement joints at the required location and elevation, with all parts rigidly secured in the required position, when shown on the plans. 4.4.2 Transverse construction joints. 4.4.2.1 Continuously reinforced concrete pavement, CRCP. Install additional longitudinal reinforcement through the bulkhead when shown on the plans. Protect the reinforcing steel immediately beyond the construction joint from damage, vibration, and impact. 4.4.2.2 Concrete pavement contraction design, CPCD. Install and rigidly secure a complete joint assembly and bulkhead in the planned transverse contraction joint location when the placing of concrete is intentionally stopped. Install a transverse construction joint either at a planned transverse contraction joint location or mid-slab between planned transverse contraction joints when the placing of concrete is unintentionally stopped. Install tie bars of the size and spacing used in the longitudinal joints for mid-slab construction joints. 4.4.2.3 Curb joints. Provide joints in the curb of the same type and location as the adjacent pavement. Use expansion joint material of the same thickness, type, and quality required for the pavement and of the section shown for the curb. Extend expansion joints through the curb. Construct curb joints at all transverse pavement joints. Place reinforcing steel into the plastic concrete pavement for non-monolithic curbs as shown on the plans unless otherwise approved. Form or saw the weakened plane joint across the full width of concrete pavement and through the monolithic curbs. Construct curb joints in accordance with item 529, concrete curb, gutter, and combined curb and gutter. 4.5 Placing and removing forms. Use clean and oiled forms. Secure forms on a base or firm subgrade that is accurately graded and that provides stable support without deflection and movement by form riding equipment. Pin every form at least at the middle and near each end. Tightly join and key form sections together to prevent relative displacement. Set side forms far enough in advance of concrete placement to permit inspection. Check conformity of the grade, alignment, and stability of forms immediately before placing concrete, and make all necessary corrections. Use a straight edge or other approved method to test the top of forms to ensure that the ride quality requirements for the completed pavement will be met. Stop paving operations if forms settle or deflect more than 1/8 inches. Under finishing operations. Reset forms to line and grade, and refinish the concrete surface to correct grade. Avoid damage to the edge of the pavement when removing forms. Repair damage resulting from form removal and honeycombed areas with a mortar mix within 24 hr after form removal unless otherwise approved. Clean joint face and repair honeycombed or damaged areas within 24 hr after a bulkhead for a transverse construction joint has been removed unless otherwise approved. Promptly apply membrane curing compound to the edge of the concrete pavement when forms are removed before 72 hr after concrete placement. Forms that are not the same depth as the pavement, but are within 2 inches of that depth are permitted if the subbase is trenchhead or the full width and length of the form base is supported with a firm material to produce the required pavement thickness. Promptly repair the form trench after use. Use flexible or curved wood or metal forms for curves of 100 feet radius or less. 4.6 Concrete delivery. Clean delivery equipment as necessary to prevent accumulation of old concrete before loading fresh concrete. Use agitated delivery equipment for concrete designed to have a slump of more than 5 inches. Segregated concrete is subject to rejection. Begin the discharge of concrete delivered in agitated delivery equipment conforming to the requirements of item 421, hydraulic cement concrete. Place non-agitated concrete within 45 minutes after batching. Reduce times as directed when hot weather or other conditions cause quick setting of the concrete. 4.7 Concrete placement. Do not allow the pavement edge to deviate from the established paving line by more than half an inch. At any point, place the concrete as near as possible to its final location, and minimize segregation and rehandling. Distribute concrete using shovels where hand spreading is necessary. Do not use rakes or vibrators to distribute concrete. 4.7.1 Consolidation. Consolidate all concrete by approved mechanical vibrators operated on the front of the paving equipment. Use immersion-type vibrators that simultaneously consolidate the full width of the placement when machine finishing. Keep vibrators from dislodging reinforcement. Use hand-operated vibrators to consolidate concrete along forms, at all joints and in areas not accessible to the machine-mounted vibrators. Do not operate machine-mounted vibrators while the paving equipment is stationary. Vibrator operations are subject to review. 4.7.2 Curbs. Conform to the requirements of item 529, concrete curb, gutter, and combined curb and gutter where curbs are placed separately. 4.7.3 Temperature restrictions. Place concrete that is between 40 degrees Fahrenheit and 95 degrees Fahrenheit when measured in accordance with TEX 422A at the time of discharge, except that concrete may be used if it was already in transit when the temperature was found to exceed the allowable maximum. Take immediate corrective action or cease concrete production when the concrete temperature exceeds 95 degrees Fahrenheit. Do not place concrete when the ambient temperature in the shade is below 40 degrees Fahrenheit and falling unless approved. Concrete may be placed when the ambient temperature in the shade is above 35 degrees Fahrenheit and rising or above 40 degrees Fahrenheit. Protect the pavement with an approved insulating material capable of protecting the concrete for the specified curing period when temperatures warrant protection against freezing. Submit for approval proposed measures to protect the concrete from anticipated freezing weather for the first 72 HR after placement. Repair or replace all concrete damaged by freezing. 4.8 Spreading and finishing. Finish all concrete pavement with approved self-propelled equipment. Use power-driven spreaders, power-driven vibrators, power-driven strike-off, screed, or approved alternate equipment. Use the transverse finishing equipment to compact and strike off the concrete to the required section and grade without surface voids. Use float equipment for final finishing. Use concrete with a consistency that allows completion of all finishing operations without addition of water to the surface. Use the minimal amount of water fog mist necessary to maintain a moist surface. Reduce fogging if float or straight edge operations result in excess slurry. 4.8.1 Finished surface. Perform sufficient checks with long-handled 10 feet and 15 feet straight edges on the plastic concrete to ensure the final surface is within the tolerances specified in Surface Test A in Item 585, Ride Quality for Pavement Surfaces. Check with the straight edge parallel to the center line. 4.8.2 Maintenance of surface moisture. Prevent surface drying of the pavement before application of the curing system by means that may include water fogging, the use of wind screens, and the use of evaporation retardants. Apply evaporation retardant at the manufacturer's recommended rate. Reapply the evaporation retardant as needed to maintain the concrete surface in a moist condition until curing system is applied. Do not use evaporation retardant as a finishing aid. Failure to take acceptable precautions to prevent surface drying of the pavement will be cause for shutdown of pavement operations. 4.8.3 Surface texturing. Complete final texturing before the concrete has attained its initial set. Drag the carpet longitudinally along the pavement surface with the carpet contact surface area adjusted to provide a satisfactory coarsely textured surface. Prevent the carpet from getting plugged with grout. Do not perform carpet dragging operations while there is excessive bleed water. A metal tine texture finish is required unless otherwise shown on the plans. Provide transverse tining unless otherwise shown on the plans. Immediately following the carpet drag, apply a single coat of evaporation retardant, if needed, at the rate recommended by the manufacturer. Provide the metal tine finish immediately after the concrete surface has set enough for consistent tining. Operate the metal tine device to obtain grooves approximately 3/16 inches deep, with a minimum depth of 1/8 inches, and approximately 1/12 inches wide. Do not overlap a previously tined area. Use manual methods to achieve similar results on ramps, small or irregular areas, and narrow width sections of pavements. Repair damage to the edge of the slab and joints immediately after texturing. Do not tine pavement that will be overlaid or that is scheduled for blanket diamond grinding or shot blasting. Target a carpet drag texture of 0.04 inches, as measured by Tex 436A, when carpet drag is the only surface texture required on the plans. Ensure adequate and consistent macro texture is achieved by applying enough weight to the carpet and by keeping the carpet from getting plugged with grout. Correct any location with a texture less than 0.03 inches by diamond grinding or shot blasting. The engineer will determine the test locations at points located transversely to the direction of traffic in the outside wheel path. 4.8.4 Small, irregular area, or narrow width placements. Use hand equipment and procedures that produce a consolidated and finished pavement section to the line and grade where machine placements and finishing of concrete pavement are not practical. 4.8.5 Emergency procedures. Use hand-operated equipment for applying texture, evaporation retardant, and cure in the event of equipment breakdown. 4.9 Curing. Keep the concrete pavement surface from drying as described in section 360.4.8.2, maintenance of surface moisture, until the curing material has been applied. Maintain and promptly repair damage to curing materials on exposed surfaces of concrete pavement continuously for at least 3 curing days. A curing day is defined as a 24-hour period when either the temperature taken in the shade away from artificial heat is above 50 degrees Fahrenheit for at least 19 hours or the surface temperature of the concrete is maintained above 40 degrees Fahrenheit for 24-hour. Curing begins when the concrete curing system has been applied. Stop concrete paving if curing compound is not being applied promptly and maintained adequately. Other methods of curing in accordance with item 422, concrete superstructures, may be used when specified or approved. 4.9.1 Membrane curing. Spray the concrete surface uniformly with 2 coats of membrane curing compound at an individual application rate of no more than 180 square foot per gallon. Apply the curing compound before allowing the concrete surface to dry. Manage finishing and texturing operations to ensure placement of curing compound on a moist concrete surface, relatively free of bleed water, to prevent any plastic shrinkage cracking. Time the application of curing compound to prevent plastic shrinkage cracking. Maintain curing compounds in a uniformly agitated condition, free of settlement before and during application. Do not thin or dilute the curing compound. Apply additional compound at the same rate of coverage to correct damage where the coating shows discontinuities or other defects or if rain falls on the newly coated surface before the film has dried enough to resist damage. Ensure that the curing compound coats the sides of the tining grooves. 4.9.2 Asphalt curing. Apply a uniform coating of asphalt curing at a rate of 90 to 180 square foot per gallon when an asphaltic concrete overlay is required. Apply curing immediately after texturing and once the free moisture, sheen, has disappeared. Obtain approval to add water to the emulsion to improve spray distribution. Maintain the asphalt application rate when using diluted emulsions. Maintain the emulsion in a mixed condition during application. 4.9.3 Curing Class E's concrete. Provide membrane curing in accordance with Section 360.4.9.1, membrane curing, for all Class E's concrete pavement. Promptly follow by wet mat curing in accordance with Section 422.4.8, final curing, until opening strength is achieved but not less than 24 hr. 4.9.4 Curing Fast Track Concrete Pavement. Provide wet mat curing unless otherwise shown on the plans or as directed. Cure in accordance with Section 422.4.8, final curing. Apply a Type 1D or Type 2 membrane cure instead of wet mat curing if the air temperature is below 65 degrees Fahrenheit and insulating blankets are used. 4.10 Sawing joints. Saw joints to the depth shown on the plans as soon as sawing can be accomplished without damage to the pavement regardless of time of day or weather conditions. Some minor raveling of the saw cut is acceptable. Use a chalk line, string line, sawing template, or other approved method to provide a true joint alignment. Provide enough saws to match the paving production rate to ensure sawing completion at the earliest possible time to avoid uncontrolled cracking. Reduce paving production if necessary to ensure timely sawing of joints. Promptly restore membrane cure damaged within the first 72 hr of curing. 4.11 Protection of pavement and opening to traffic. Testing for early opening is the responsibility of the contractor regardless of job control testing responsibilities unless otherwise shown on the plans or as directed. Testing result interpretation for opening to traffic is subject to approval. 4.11.1 Protection of pavement. Erect and maintain barricades and other standard and approved devices that will exclude all vehicles and equipment from the newly placed pavement for the periods specified. Protect the pavement from damage due to crossings using approved methods before opening to traffic. Where a detour is not readily available or economically feasible, an occasional crossing of the roadway with overweight equipment may be permitted for relocating equipment only but not for hauling material. When an occasional crossing of overweight equipment is permitted, temporary matting or other approved methods may be required. Maintain an adequate supply of sheeting or other material to cover and protect fresh concrete surface from weather damage. Apply as needed to protect the pavement surface from weather. 4.11.2 Opening pavement to all traffic. Pavement that is 7 days old may be open to all traffic. Clean pavement, place stable material against the pavement edges, seal joints, and perform all other traffic safety related work before opening to traffic. 4.11.3 Opening pavement to construction equipment. Unless otherwise shown on the plans, concrete pavement may be opened early to concrete paving equipment and related delivery equipment after the concrete is at least 48 hr old and opening strength has been demonstrated in accordance with Section 360.4.11.4, early opening to all traffic, before curing is complete. Keep delivery equipment at least 2 feet from the edge of the concrete pavement. Keep tracks of the paving equipment at least 1 foot from the pavement edge. Protect textured surfaces from the paving equipment. Restore damaged membrane curing as soon as possible. Repair pavement damaged by paving or delivery equipment before opening to all traffic. 4.11.4 Early opening to all traffic. Concrete pavement may be opened after curing is complete and the concrete has attained a flexural strength of 450 psi or a compressive strength of 3200 psi. Except that pavement using Class E's concrete may be opened after 24 hr if the specified strength is achieved. 4.11.4.1 Strength testing. Test concrete specimens cured under the same conditions as the portion of the pavement involved. 4.11.4.2 Maturity method. Use the maturity method, TEX 426A, to estimate concrete strength for early opening pavement to traffic unless otherwise shown on the plans. Install at least 2 maturity sensors for each day's placement in areas where the maturity method will be used for early opening. Maturity sensors, when used, will be installed near the day's final placement for areas being evaluated for early opening. Use test specimens to verify the strength, maturity relationship in accordance with TxDOT 426A, starting with the first day's placement corresponding to the early opening pavement section. Verify the strength, maturity relationship at least every 10 days of production after the first day. Establish a new strength, maturity relationship when the strength specimens deviate more than 10% from the maturity estimated strengths. Suspend use of the maturity method for opening pavements to traffic when the strength, maturity relationship deviates by more than 10% until a new strength, maturity relationship is established. The engineer will determine the frequency of verification when the maturity method is used intermittently or for only specific areas. 4.11.5 Fast Track Concrete Pavement. Open the pavement after the concrete has been cured for at least 8 hr and attained a minimum compressive strength of 1800 psi or a minimum flexural strength of 255 psi when tested in accordance with section 360.4.11.4.1, strength testing, or section 360.4.11.4.2, maturity method, unless otherwise directed. Cover the pavement with insulating blankets when the air temperature is below 65 degrees Fahrenheit until the pavement is open to traffic. 4.11.6 Emergency opening to traffic. Open the pavement to traffic under emergency conditions, when the pavement is at least 72 hr old when directed in writing. Remove all obstructing materials, place stable material against the pavement edges, and perform other work involved in providing for the safety of traffic as required for emergency opening. 4.12 Pavement thickness. The engineer will check the thickness in accordance with TxDOT 423A unless other methods are shown on the plans. The engineer will perform one thickness test consisting of one reading at approximately the center of the paving equipment every 500 feet or fraction thereof. Core where directed, in accordance with TxDOT 424A, to verify deficiencies of more than 0.2 inches. From plan thickness and to determine the limits of deficiencies of more than 0.75 inches. From plan thickness. Fill core holes using an approved concrete mixture and method. 4.12.1 Thickness deficiencies greater than 0.2 inches. Take 1/4 inches. Diameter core at that location to verify the measurement when any depth test measured in accordance with TxDOT 423A is deficient by more than 0.2 inches. From the plan thickness. Take 2 additional cores from the unit, as defined in section 360.4.12.3, pavement units for pavement adjustment at intervals of at least 150 feet and at selected locations if the core is deficient by more than 0.2 inches, but not by more than 0.75 inches from the plan thickness, and determine the thickness of the unit for pavement purposes by averaging the length of the 3 cores. In calculations of the average thickness of this unit of pavement, measurements in excess of the specified thickness by more than 0.2 inches will be considered as the specified thickness plus 0.2 inches. 4.12.2 Thickness deficiencies greater than 0.75 inches. Take additional cores at 10 feet intervals in each direction parallel to the center line to determine the boundary of the deficient area if a core is deficient by more than 0.75 inches. The engineer will evaluate any area of pavement found deficient in thickness by more than 0.75 inches, but not more than 1 inch. Remove and replace the deficient areas without additional compensation or retain deficient areas without compensation, as directed. Remove and replace any area of pavement found deficient in thickness by more than 1 inch. Without additional compensation. 4.12.3 Pavement units for pavement adjustment. Limits for applying a pavement adjustment for deficient pavement thickness from 0.20 inches to not more than 0.75 inches. Are 500 feet of pavement in each lane. Lane width will be as shown on typical sections and pavement design standards. For greater than 0.75 inches. Deficient thickness, the limits for applying zero pavement or requiring removal will be defined by coring or equivalent non-destructive means as determined by the engineer. The remaining portion of the unit determined to be less than 0.75 inches. Deficient will be subject to the payment adjustment based on the average core thickness at each end of the 10 feet interval investigation as determined by the engineer. Shoulders will be measured for thickness unless otherwise shown on the plans. Shoulders 6 feet wide or wider will be considered as lanes. Shoulders less than 6 feet wide will be considered part of the adjacent lane. Limits for applying payment adjustment for deficient pavement thickness for ramps, widenings, acceleration and deceleration lanes, and other miscellaneous areas are 500 feet in length. Areas less than 500 feet in length will be individually evaluated for payment adjustment based on the plan area. 4.13 Ride Quality. Measure ride quality in accordance with item 585, ride quality for pavement surfaces, unless otherwise shown on the plans. 5. Measurement. This item will be measured as follows. 5.1 Concrete pavement. Concrete pavement will be measured by the square yard of surface area in place. The surface area includes the portion of the pavement slab extending beneath the curb. 5.2 Curb. Curb on concrete pavement will be measured by the foot in place. 6. Payment. These prices are full compensation for materials, equipment, labor, tools, and incidentals. 6.1 Concrete pavement. The work performed and materials furnished in accordance with this item and measured as provided under measurement will be paid for at the adjusted unit price bid for concrete pavement of the type and depth specified as adjusted in accordance with section 360.6.2, deficient thickness adjustment. 6.2 Deficient thickness adjustment. Where the average thickness of pavement is deficient in thickness by more than 0.2 inches, but not more than 0.75 inches, payment will be made using the adjustment factor as specified in Table 2 applied to the bid price for the deficient area for each unit as defined under Section 360.4.12.3, Pavement Units for Payment Adjustment. Table 2. Deficient Thickness Price Adjustment Factor. See table in specifications. 6.3 Curb. Work performed and furnished in accordance with this item and measured as provided under measurement will be paid for at the unit price bid for curb of the type specified.